Welcome to lesson 6.2. In this lesson, we're going to move away from 2 by 2 systems of equations and talk about 3 by 3 systems of equations. Now, before we begin, let's just slightly remind ourselves of our 2 by 2. A 2 by 2 means 2 equations, 2 variables. And what it usually ended up looking like was 2 lines. And our answer was the point that the lines have in common. The point that they share. That was our answer, x comma y, that point that they have in common that they share. Now, and that was when we looked at 2 equations, 2 variables. Today we're going to start to look at 3 by 3s, meaning 3 equations, 3 variables. And there's a couple key differences in how we visualize this. Instead of looking at flat lines now, we're going to be looking at planes. A plane is like a flat line that goes forever in one direction. Let me give you an example. Right here, this dark blue one, that is a plane. It extends forever and ever in this direction, this direction, this direction, and this direction. So this is only a piece of that gigantic dark blue plane. And in this dark blue plane, we're going to take 3 of those planes, a 3 by 3 system, and we're looking for the point that all 3 planes have in common. So you'll notice in this picture, there's no point that all 3 planes share. No point that they all have in common. So this would be a good example of a no solution system. There's no point that they all share. But that's kind of what we're visualizing here. 3 equations, 3 variables, and we're trying to find the point that they share, the point that they have in common. So we're going to start right here with example 1. Now, for this chapter, 6.2, we're basically going to be talking about 3 by 3 systems for the rest of the chapter. For 6.2 through 6.6, it's all 3 by 3 systems. And every day, we're just going to learn a different method for solving these problems. Today's method, 6.2, is not the most eloquent method. It's not the most graceful. It's very just blunt force, let's do this. So there's a lot of gray area here in this method. There's a lot of just throw things at it and see if it works. But the kind of point to that is that as we do different methods in 6.3, 6.4, 6.5, and 6.6, you can see that there are a lot better methods for solving this than the first one we're doing today. But today's really just to serve as an introduction to solving these methods. So here's what we're going to do to solve these 3 by 3s. We're going to start by forcing it to be a 2 by 2. And that outlines this process right here in this box. So we're going to pick one of the variables, x, y, or z. It really doesn't matter which one. And we want to eliminate that variable from one pair of equations and eliminate that variable from a different pair of equations in order to force us to get a 2 by 2 system. And then the reason we get a 2 by 2 is then we can solve that using substitution or elimination, whichever method you prefer from 6.1. So that's kind of what we're doing today. We're blunt forcing it to make it look like a 2 by 2, so then we can solve it using substitution or elimination. So let's do step 1. We're going to pick one variable that I want to eliminate from 2 pairs of equations. I can pick x's, y's, or z's. It really doesn't matter. So for today, let's just pick x's. So step 2, I'm going to pick a pair of equations and I'm going to eliminate the x's from that pair of equations. It really doesn't matter which pair of equations you pick. You can pick the first and the second, you could pick the second and the third, or you could pick the first and the third. Any of those pairs of equations work. So for today, let's just start by picking the first and the second. So I picked a pair of equations and I'm going to eliminate the x's from this pair of equations because the x's is a variable I picked at the beginning. So I'm going to zoom in here. I need to eliminate the x's. So that means I'm going to multiply this one by 2, this one by negative 3. So then my x's will stack up and eliminate from each other. So let's multiply this one by 2. 6x minus 2y plus 2z equals 6. And the second one by negative 3 plus 12y minus 9z equals 16 times negative 3 is negative 48. Now stack them, eliminate my x's, which was the point. I picked a pair of equations and eliminate the x's from them. Negative 2y plus 12y is 10y. 2z minus 9z is negative 7z. And negative 48 plus 6 is negative 42. So that's our step 2. We picked a pair of equations and we eliminated the x's from them. And I got this equation as a result. So step 3, I'm going to pick a different pair of equations and eliminate the x's from that pair. So I did the first and the second. So now I can either do the second and the third, or I can do the first and the third. So let's just do the second and the third. I'm just going to pick that for my pair of equations. So this is my second pair of equations, and once again, I'm going to eliminate the x's from them. That's the goal. Make the x's go away. So let's times this one by a negative 2, so then I can stack the x's and make them disappear. So the first equation I didn't change at all. The second equation I times by a negative 2. And now my x's stack. Beautiful. Negative 4y plus 2y is a negative 2y. 3z minus 2z is a positive z equals 6. So far so good, I think. Now, step 4, if you look at our answers from steps 2 and 3, I have a 2 by 2 left. So let's write that 2 by 2 I have. I have 10y minus 7z equals negative 42, and negative 2y plus z equals 6. And I can solve that 2 by 2 using substitution or elimination, any of those methods that we learned in 6.1, which was the point all along, was to blunt force to make it look like a 2 by 2. So now I can solve it. So I can use substitution or elimination here. It really doesn't matter which one. I personally prefer elimination. So I'm going to take my 2 by 2 system. And I'm going to use elimination. That's just my personal preference. It really doesn't matter though. So I'm going to times this one by 5. So then I can get the y's to stack up. Plus 5z equals 30. My y's now go away. I get negative 2z equals negative 12. Divide by negative 2, and I finally get my first answer, that z is 6. So a little review here. We started by picking any of the 3 variables, x, y's, or z's. We picked a pair of equations and eliminated that variable from it. We picked a different pair of equations, eliminated that variable from it, took the 2 by 2 that resulted from steps 2 and 3, and we're solving that 2 by 2 using substitution or elimination, anything from 6.1. And that gets us our first answer. Now remember, we do also need to find y and x, so I need to plug z back in to one of my 2 by 2 equations to solve for y. So I'm going to pick the second one. Plug in z is 6. So minus 6 to both sides, negative 2y equals 0. And I get that y is 0. So now I have my x, or my z and my y point. Last thing I need to do is find my x point. So I can pick any of my 3 original equations, plug in y, plug in z, and solve for x. So let's do the third equation. So plug in 0 for y, plug in 6 for z. So I get x plus 6 equals 5, and I get x equals negative 1. And now that I have x, y, and z, I can write out my coordinate pair, negative 1, comma 0, comma 6. That is the pair that all 3 equations have in common. All 3 equations share. We have a good visualization of what this looks like right here. So here you can see my 3 different planes we talked about at the beginning. And this little white dot in the middle, that's my negative 1, comma 0, comma 6. That is the one point that all 3 flat planes have in common. The one point that they all share. So that is our first example for blunt force solving a system. One last review, we picked a variable, picked a pair of equations, eliminated that variable, picked another pair, eliminated that variable, wrote out the 2 by 2 that gave us. We solved that 2 by 2, and then step 6, we solved for everything else. So let's try that again in the next example in the next video.